friends, welcome to video lecture on engineering mechanics. In the today's lecture, we'll discuss about the numericals on system of Coplanar forces. So let us start the next problem. Two concurrent forces P and Q act at point O such that their resultant act along x-axis. Determine the magnitude of Q and hence the resultant, okay, R. So in this case, if we just say the problem is given like this, okay, the magnitude of the P with us, then Q, okay, given here. So this is the case of concurrent force system. So in this problem, the resultant of the two forces act along the x-axis. This information is given, okay, here. The resultant act along x-axis, okay. So clearly mentioned here. That's why I just in the answer just mention here. It is given that the resultant of the two forces acts along the x-axis. So what it implies, what it indicates, this implies this way. So summation of f of x, the horizontal component of this one, r, resultant r lies along the x-axis, means r is along the x-axis. What's about the along y-axis? Summation of f of y must be equal to 0. Okay, this is the information with us. Okay, so as per our first step, so what's about the step number 1? Resolving forces along x and y directions. Okay, so you need to resolve the forces along x and y direction. Okay, for that I'll use the same diagram. Okay, same diagram here. For the answer you make the redraw the diagram once again. Okay, so because of the space limitations I'll just use the same diagram. So here now resolve here. So what's about this one? This indicate the component of the P along the x direction, this one along the y direction. So this angle with us 30 degree. So what's about the horizontal component? 480 cos of 30. As per our previous discussion, the component adjacent with the angle must be cos component. So remaining one must be sine component. So 480 sine of 30 degree in this way. So what it indicate here? 4, 3. Okay, this is nothing but the slope given here. Okay, so what's about the value for this one? So get the value for this angle here. So I can get the angle, can get the value for that angle in this way. Here just mention or just tan of that particular angle, tan of theta equals to this side divided by this one. Okay, so that we can get the opposite of this one, nothing but this angle. Okay, if I consider this angle as theta, so sine of theta is nothing but 4 divided by 3. So get the value for theta. Theta is nothing but the tan inverse of 4 divided by 3. Okay, so you can just do this step with the help of calculator. Okay, 4 by 3. So here we can get the value for, actually tan inverse is not written, tan inverse of 4 by 3. What do we get here? 53.14. No, sorry, 53.13 degree. So once we get this angle, remember, okay, this one front side divided by adjacent side. Okay, means you can get the tan of theta. So opposite angle of this one is nothing but the theta. That's why the theta is written here. Okay, so my target is here to first of all resolve this cube into its components. So first component in horizontal direction, another component will come in vertical direction. What's about this angle theta? Theta with us 53.14, 53.13. Okay. So what's about the horizontal component? Q, as the value for the Q is unknown to us. Okay. Just write this one in terms of Q into cos of 53.13. Okay, like this. What's about the next one? Q sine of 53.13 will come here. Okay, like this. So once we complete the resolution step, already this information is also with us. Okay, move towards the another step. So what's about the next step with us? So summation of all the forces along the x direction. So get the summation of all the forces along the x direction. Okay, or step number 2 with us. What's about that step? Summation of all the forces along the x direction by considering this as sign convention. Okay, always do this sign convention here so that easy for us to get the directions. Okay, so in this case, summation of f of x, just focus only on the horizontal forces. So first force is here, whose magnitude with us 480 cos of 30, running towards which direction? This one running towards the positive side of the x-axis, means you need to consider this one as positive. Similarly, what's about the next one? Plus q cos of 53.13. okay, so this force with us, this force is also running towards the right direction, so consider this force as force also as positive. And we know the summation of f of x, that actually given in the problem, that must be equals to r. Okay, so give equation number 1 for this, because here two unknowns with us. Okay, we can get this in terms of equation number 1. Okay, now move towards the next one. Get the summation of f of y by considering this as sign convention. Okay, whatever the forces running vertically in downward direction, consider that forces as negative, and the forces which are running vertical in upward direction, consider that forces as positive. Okay, so by considering this as sign convention, so what's about the this force? 480 sine of 30 is here. Okay, sine of 30 with us here. And what's about this one? This force vertically in downward direction, whose magnitude q sine of 53.13, like this. So this force we are considered, this force we are considered. Okay, and we know the summation of f of y already given in the problem, equals to 0. Okay, give equation number 2. Solve equation number 2. Okay, because only single unknown with us, so therefore q sine of 53.13. okay, if I take towards the another side, automatically the sign for this one becomes positive. So 480 divided by sine of 30. So solve this, q equals to 480 sine of 30 divided by sine of 53.13. okay, solve this, you can get this one, 480 multiplied by sine of 30 divided by sine of 53.13. So after solving, we can get the value for the q as 300 Newton. So once we get the value for the q, okay, automatically you can get the value for the r. Just substituting q in equation 1. So what do we get here? Equation 1 with us, 480 cos of 30 plus the calculation for the q done in this step. So substitute the value for q as 300. So cos of 53.13 equals to r. Okay, solve this and get the value for r. What's about the value for the r? After solving, you can get the value for r as 480 multiplied by cos of 30 plus 300 multiplied by cos of 53.13 equals to 5 0.69 Newton. So as this positive value comes, means this is running towards the right direction. This is the answer regarding the R, and the answer for the Q. I hope this problem cleared you. Okay. So let us start next problem. For the system shown, determine the required value of alpha if resultant of 3 force is to be vertical. Okay, this is the important point given. And the second one, the corresponding magnitude of the resultant. Okay. So in this way problem, okay, in front of you, our target is to find out the value for this one unknown alpha as well as corresponding value of the resultant. Okay. So for that, just redraw this diagram and show the forces. Before that, it's very important to know the information. Okay, this one, this information is given. The resultant of the 3 vertical forces. Sorry, resultant of the 3 forces is to be vertical. This information with us. So with the help of this information, we have to write the relation. This is the resultant force is vertical. It implies summation of f of x equal to 0 and next one summation of f of y equals to r. Okay, so in this way the information is given in the problem. Okay, so as far as concerned with the step number 1, what's about the step number 1? Redraw this diagram and just resolve the forces. Okay, and redraw this diagram. Redraw this diagram like this. This angle is given alpha here. Okay, this one with us 30 degree. Okay, this angle is alpha. This one given 200 Newton. This one given 150 Newton. This one given 100 Newton. Okay. So first of all, just resolve the forces. I'll show that resolution of force with some different color so that you can easily identify. So this one, this angle with us alpha. What's about this force? 100 cos of alpha. Okay, so what's about this one? 100 sine of alpha. At the same time, resolve this force. So this angle. So as per our previous discussion, always you need to consider the angle made by the particular force either with the x-axis or with the vertical axis. So in this case, the angle between these two forces is given. So here in this case, we need to consider the angle made by this force with the x-axis. So what's about the angle made by this force with the x-axis? This must be correct, alpha plus 30. Okay, so what's about the horizontal component of this one? 150 cos of alpha plus 30. In this we can get the angle, and similarly here we can get the 150 sine of, so what's about the angle? Alpha plus 30 here. Now try to resolve this force also. Here we can get the alpha, same angle continued here. So what's about this one? 200 cos of alpha, here the 200 sine of alpha with us. Now the resolution part is over. Now focus on the first one, step 1. Step number 1 is what? Clearly mentioned, resolving the forces. Resolving the forces along x and y directions. Okay, so resolution part is what? What's about the next one? Step number 2, summation of all the forces from the x direction by considering this as sign convention. Okay, positive. Okay, so the value for this one, summation of f of x, already with us 0. Okay, now focus on the various forces along the x direction. This one with us 100 cos of, so what's about this one? 100 cos of alpha running towards right direction. Okay, write this force clearly here. Right, cos of alpha. The next force is here, running exactly in opposite direction, running towards the negative side of the x-axis. 100 cos of alpha must be a negative. Okay, sorry, 200 cos of alpha must be negative. Sign should be given for this one. Okay, so what's about this force running towards the right direction? Consider this force as positive. Okay, so alpha plus 30 degree with us. Okay, now just if you look towards this equation, only alpha is unknown. Okay, means you have to solve this equation for the unknown value, that is alpha. Okay, now just continue this one. 100 cos of alpha minus 200 cos of alpha plus 150. What's about the formula for this one? Cos of a plus b. From that formula, just expand this term. Okay, expand this term. Yeah, so cos of alpha. So what's about the expansion of this one? Cos of alpha into cos of this one 30 degree minus, in short, cos of a plus b. What's about the formula? Cos of a into cos of b minus sin of a into sin of b. Okay, this is the formula with us. So from that formula I can write here sin of alpha into sin of 30 degree. Okay, sin of 30 degree in this way. So just continue. Already towards the left side, the 0 with us. 100 cos of alpha minus 200 cos of alpha means here you can get the minus 100 cos of alpha. So about the next terms, here 150, just multiply by this 150 term to inside terms. 150 cos of alpha into 1 cos of 30 minus 150 into sin of alpha into sin of 30. Okay, just try to get the clear answer for the minus 100 cos of this one alpha. So 150 multiplied by cos of 30. 150 multiplied by cos of 30. What's about this one? 129.90. Okay, into cos of alpha minus, what's about this? 150 multiplied by sin of 30. So what do we get here? We can get 75 into sin of alpha. Okay, already it was the left side of this equation, 0 value with us. Okay, now try to solve this one. You can easily solve this. Okay, so 100 cos of alpha plus this one, how much we can get here? 29.90 cos of alpha. Here the 75 with us. Take this 75 towards the another side. Just take this 75 here. 75 sin of alpha. Okay, the sign of the same will changes. Therefore, sin of alpha divided by cos of alpha. Just take this term here. So solve this. 29.90 by 75 equals to, so whatever the value comes here, nothing but 8.67. Okay, so sin divided by cos, what's about the meaning? Tan of alpha. Okay, tan of alpha equals to 3967. Okay, so take the tan inverse of this one so that we can get the answer for the same. So the value for the alpha here found is nothing but 2173 degree. In this way you can get the value for the alpha. Write the value for the alpha here so that clearly visible to you. For alpha equals to 0.74 degree. So our next task is to get the value for R. Okay, for that just continue for the next step. Okay, just continue that step here so that you can get it. Summation of f of y equals to by considering this as sign conventions. And give the minus sign for this one, and you have to consider the positive sign for this symbol. So what's about the summation of f of y? Just focus only on the vertical forces. First one is here, next one is here, next one is here. Okay, so just pick up one by one and write here. 200 sin of alpha is here. Okay, so next force is here. Just write here. The space limitation. So here, the value for the summation of f of y is also with us, the minus 3. This one r with us here. 200 sin of alpha with us, give the negative sign for this one, and next one 100 sin of alpha with us, give the negative sign for this term also, minus sign, just give the minus sign for this one because this force is vertically in downward direction. So 150 alpha plus this one 30. Okay, so alpha already a value calculated by us in the previous step. Substitute the value of alpha here. Sin of alpha with us 21.74. Okay, just substitute the value of alpha also here 21.74 and minus 150 into sin of alpha with us 21.74 plus this one 30. So do the calculation for the this step so that we can get the value for R. 0.74 plus 100 multiplied by sine of 21.74 plus 150 multiplied by sine of 21.74 plus 30 degree. Okay, so if you look towards the answer for this one, 228.89. okay, 899 means here you can get 90. Okay, in this way. So if you just see the sign for this one as minus will come. So at last you can just write the answers here. Your answer, alpha with us 21.74 degree and R with us after calculation 228.90 Newton vertically in downward direction. So this symbol indicate that the direction for this one R is in downward direction. It's not necessary to give the sign here once again. So this indicate in downward direction means the value for the R is negative. Let us start the next problem. The striker of a carom board lying on the board is being pulled by 4 players as shown in figure. The players are sitting exactly at the center of 4 sides. Determine the resultant of forces in the magnitude and direction. Okay, so the problem is given like in this way. So the 4 players sitting at a center of every side. Okay, so the first player is here. Okay, let us consider this one. A is first one, B is second one, third one is here, next one is here. Okay, in this way the problem with us, problem in front of us. So our aim is to get the resultant of all the forces. Okay, So here the direct value of the theta is not given. Angle made by any force or this one 20 Newton, 25, 10 or this one 15 Newton. The angle is not given. So angles are available with us with the help of this one sides length of the sum of the actually points given. The location of the striker is here. Okay, everybody try to pulling that striker towards their end. Okay, so here here is the striker. Okay, I'll just make that striker color. Okay, the striker. So if you just say our first aim is to get the angle made by every force. For that I'll just draw here line for the answer. Just repeating, redraw this diagram because of the space limitations. I'm just using the same diagram. Okay, so what's about this one? Let us consider this angle is nothing but the theta 1. Okay, similarly if you just see here, just consider this angle is nothing but the theta 2. Okay, so what's about this one? This angle just consider here theta 3. Consider this angle as theta 4. So geometry, from the geometry just try to get the value for this one theta 1 from geometry. What's about this theta 1? For that, if I look towards this this length, theta 1 is nothing but here. So what's about this length? This length up to here 300 mm is given, up to from this point up to a center of this one 250 with us. Okay, so can you tell me what's about this length? 250 mm. Okay, so the location of the first one player with respect to this corner is nothing but the 400 mm. If I get this one small distance and this length, okay, easily you can get the relation for the tan as trigonometric function here. If I consider that tan theta 1, okay, so what's about this front side? The location of this player, first player with this corner, total distance with us 800 mm. So half of this one 400 mm. Okay, so what's about this length? So total length with us 400. This length, how much this length? Okay, for this length is given 250 mm. Okay, so if I write this relation in this way, total 400, out of this 400, this one with us 250, so 400 minus 250 divided by, okay, so this is the front length. So what's about this one? This is nothing but total with us 800 mm. So out of this 800, this one 300 mm up to here, means what's about the remaining one? Remaining one is nothing but 800 minus this 300. Okay, so solve this relation and get the value for the theta 1. Okay, so in this case, right here direct tan inverse of what's about this one? 400 minus 250 divided by 800 minus 300. Okay, so in this way get the value for the theta 1. Therefore theta 1 is nothing but 16.69 or here 70. You can get the angle theta 1. Okay, similarly get the value for the next one theta 2. For this, if you just focus on the theta 2 shown here, so what's about this length? This length we can get with the help of this length. Okay, so this one with us 300, so this length with us 300. The player is sitting at the middle of that, which one? Carom board. So this one with us 300, total with us 400. So out of this, so what's about this length? Okay, so for that I'll just write here relation geometry tan of theta 2 equals to total with us 400. Total means from the center of this up to here. So 400 minus what's about this length? 300 mm is given, 300 divided by, so my next target is to get the value for this one, because taking the relation for writing relation for here tan, okay, means we need the front side divided by adjacent side. So what's about this one? So total height with us 800, so out of this 800 we know this one 250. So what's about this one? Nothing but the 800 minus 250. So solve this relation and get the value for theta 2. Okay, get the tan inverse like this one, 400 minus 300 divided by 800 minus 250. Okay, so after solving we get the value for the theta 2 as here 10 degree, 10.30 degree. Okay, like this. So once this point is what, move towards the next one. My target is to get the value for tan of theta 3. So tan of theta 3 is nothing but, for that you need to use this one, this triangle. Okay, first of all get this length. Again get this length. Total length with us 800. Okay, so out of this 800, 250 is here, 250 length is here. Okay, so player is sitting at the middle of this. So how can you get the this length? This length is nothing but 400 minus 250. Okay, divided by, what's about this length? This length is already given in the problem, 300 mm. Okay, so solve this and get the value for theta 3. You can get the value for tan of theta 3 or theta 3 in this way, 100 minus 250 divided by 300. Okay, solve this and get the value for theta 3 as 26.565. Right here 57. Okay, in this way. So once this point is what, easily we can just move towards the next point. So here tan of next one 4, and 4 is nothing but this side. I consider this triangle. This triangle you need to consider. So what's about this length? So this length up to here we know 400. Okay, out of this one 300 with us means 400 minus 300, we can get this length. So what's about this one? 250 with us. Solve this, and inverse of 400 minus 300 divided by 250. Okay, so after solving we get the value for theta 4 as 21.80. Now once we get the value for all the thetas, now our task is very easy. So you need to resolve the every force. Okay, I'll resolve the every force. So horizontal component of this one will come like this one, vertical component of this, similarly horizontal component and vertical component. Okay, so here we can get the horizontal, vertical, here we can get the vertical and horizontal component. Focus on that red components only and just try to write the forces. Here already considered first one as 20 Newton. So what's about the horizontal direction? Component in the horizontal direction 20 cos of theta 1. I'll write here direct value for the cos so that we can simplify easily. Here the cos of 16.70 degree. Okay, this angle, and this is the force component with us. So what's about the vertical component of the same force? 20 sine of 1617. Now if you look towards this one, the angle made by this force with the vertical line. So what's about this component? This component must be a cos component. So 25 cos of theta 2 with us 10.3 degree. Okay, similarly what's about the component of this one? 25 sine of 10.3. okay, similarly move towards the next one. Here the theta 3 with us. Okay, so what's about this one? Horizontal component. I'll write that component here so that clearly visible to you. 10 cos of theta 3 with us 26.57 degree. Okay, similarly just write the information regarding this one. 10 sine of 26.57, clearly visible to you. So this one, next one. Now the angle made by this 15 Newton with the vertical axis. So this component must be cos component. Okay, write this one here. Cos of theta 4 with us 21.80. This one with us 15 sine of 21.80. Okay, so all the components with us Now first step is also over. Okay, resolution of the part is also over. We get the angle. Okay, so first step is nothing but here I'll just mention your step already, that step done by us. Step number 1, resolution of forces or resolving forces, okay, along x and y directions. Okay, this step is already over, that's why directly move towards the next step. Okay, I'll just continue that step second here, so that that equation, all the forces listed here are clearly adjustable in given space. Okay, step number second, but summation of all the horizontal forces by considering the sign convention, like this one must be negative, this one must be positive. Okay, equals to, so in this case just focus on the horizontal forces. This force is running towards right direction, this one 20 cos of 16.70. okay, then next one, this force is also running towards the right direction, so need to consider this force as also positive, this force. Okay, just focus on this force 25 sine of 10.30. okay, so this force running towards the which one, right direction, that's why the force is considered as positive. Now focus on the next one, this force whose magnitude 10 cos of 26.57. this force is running in opposite direction, so give the minus sign for this one, 26.57. okay, similarly if you just consider the next force, the magnitude for this one is positive, 15 point sine of 21.80. okay, this is about the summation of f of x. Do the calculations and check the answer for the same. I will just put all the values here, so that I can get the answer. 10.70 plus 25 sine of 10.30, 10 multiplied by this cos of 26.57 plus 15 sine of 21.80. okay, this become equal to button. So we can get the value for this one as 20.25 Newton. okay, now move towards the next one, summation of f of y, by considering this as sign convention. Here this one negative, this one positive. okay, so what's about the vertical forces? Now pick up one by one vertical force carefully. This one, first one, second one, third one, fourth one. okay, these three forces are running vertical in upward direction and one in downward direction. okay, so three forces must be positive. I'll write the three forces one by one. 20 sine of 16.17. okay, first one is here, give the positive sign for this. Just move towards the next one, 25 cos of 10.30. next one is here, plus 10 sine of 26.57. okay, here is the next force, and this one vertically in downward direction, 15 cos of 21.80. okay, at the same time do the calculation, take the value for the 10. 20 sine of 16.17 plus 25 cos of 10.30. okay, plus 10 multiplied by sine of 26.57 minus 15 multiplied by cos of 21.80. okay, so do the calculation, take your answer. Here you get the answer as 20.21. okay, so if you look towards this one, the positive value with us, just move towards the next step. Resultant r equals to square root of summation of f of x square plus summation of f of y square. okay, put the value for this one, as 20.25, the first one, plus next one with us 0.71. Okay, solve this step. Put of 20.25 square of this, then 20.71 square of this. Okay, get the answer for the R equals to 28.96. Newton. Now our task is to find out the value for the theta as well as find the location for that R. Okay, so just continue the next step here. Get the value of theta, that is inclination made by the this one R, mention your step number 3. Inclination by R with x-axis. Okay, for that just consider this one, tan theta equals to summation of f of y divided by summation of f of x. Okay, so after solving we can get the value for the theta, and here write direct answer for this one. Here we found the value for the resultant R equals to 45.87. okay, and just check the sign for the summation of f of x and f of y, as both values are positive. Okay, so the R lies in which quadrant? This symbol indicate that the R lies in first quadrant. Okay, so the value for the theta with us 45.87 degree, and the value for the R with us 28.96. okay, Newton. This is the answer. I hope the answer clear to you. So whatever the problems discussed in the today's lecture, I hope problems clear to you.